Yes, good morning, all of you. If my voice is audible, if I'm audible,
Yes,
Yes,
sir.
sir.
Yes, sir.
scan this QR code for today's attendance. Yeah, is it scanned? All of you have scanned this attendance. Is it done? Yes. Okay, so let's start the session. So I hope it is clear to all of you is what we are discussing in yesterday or day before yesterday class, how to convert, how to calculate the uh, basically the number of what is the size of the secondary memory, what is the size of the primary memory, and what is the how to calculate the logical address and how to calculate the physical address. Okay, so now today we are going to learn a new problem. It is how to calculate the size of the page table. Fine. Yes. So what type of numerical we are going to today solve? So we will today we learn how to calculate the size of the page table. Okay. So let me draw first. So suppose it is given. Now suppose we know that CPU is always going to generate what? CPU क्या करेगा हमसे generate क्या कौन सा address generate करता है? It is always going to generate a logical address. Yes or no? It is always going to generate a logical address. Uh, this logical address is basically consists of two things. One is your page number and second is your offset address. Now this page number, okay. So to reduce the access time, so now what I will do, so I will having a page table here. Now what we are having, now this is my page table. Now this page table consists of different frames, okay, different frame numbers. Fine. Now suppose I say this consists of different address of the frame number, okay. This will be have different address of the frame. Now this frame is extracted here. Now it will be gives you physical address. Now this physical address consists of two things. One is your frame and second is your offset, which is basically same as that of logical address. Okay. What it is done now it will be giving you the physical address. Now this physical address is basically associated with the main memory. And is basically associated with the main memory where we are having a different frame of same partition. This is my main. Now the question is, okay, the question is now we have to calculate the size of this page table. What will be the size of this page table? Fine. How to calculate the size of this page table? So what is given? Now they are given the question. The main memory size is given. Okay. Main memory का size दिया हुआ है, which is your 256 MB. Okay. The main memory size is 256 MB. 256 MB. Then your page size is given. Page size is given, which is equal to 4 KB. Okay, 4 KB. Then your logical address, number of bit using logical address is also given, which is equal to 40 bytes. Then your process size is given. What is given? The size of the process. Okay, size of the process. What will be the size of my process? Process size is given. Fine. Process size is given. The process size is your 4 MB. Okay, the process size is 4 MB. Fine. Now what we have to calculate? Now we have to calculate the size of the page table. Now, for this process, what will be the size of my page table? Okay, what will be the size of my page table? Fine, I have to calculate the size of this page table. That means I have to calculate what will be the size of this page table for this particular process of, so I am saying this is process P, for this process of 4 MB. So what will be my size of the page table? So is it clear to all of you what we are going to calculate? Any doubt? Yes? Is that clear to all of you what we are going to calculate? Is that
Yes,
audible?
sir.
Fine. So we have to go to calculate the size of this page table. Okay, so now let us understand how to calculate. So what is given? Now initially what is given? So we have given the main memory size, which is your 256 MB. So as we know, अगर main memory का size दिया, what I can calculate? Can I calculate this? How many bits are used for this physical address? Yes or no? If the main memory is given, okay. If the main memory is given, or size of the main memory is given, can I calculate how many bits are used? Yes or no? Yes, you can calculate. So what will be the number of bits? What will be the size number of bits? So what will be how many bits are used for physical addressing? How many bits are used for physical addressing? कितना bit use होगा? Now if it is byte addressable, so it will be now this 256. Okay, the 256 will be equal to what? Or 256 MB is equal to, now suppose I am telling this, there is m bits are used. Okay, now assume that m bits are used. Now it will be equal to what? 2 to the power of m into 1 byte. Okay? Now this can be written as 2 to the power of m can be written as, now I can write this 256 equal to what? 2 to the power of 9, and this mb can be written as 2 to the power of 20, and this is my byte by 1 byte. ठीक है? Now this goes cancel. Now this will be 2
Sir,
to
2
the
to the
power of,
power 8 now.
yeah, 256 is 2 to the power of 8. So it will be 2 to the power of 28. Now what is the value of m? M equal to 28. Clear? Now what is the value of this m? Now this value of m is 28. That means this value is 28. That means how many bits are used? How many bits are used for physical addressing? 28 bits are used for physical addressing. Fine. Next, what is given? The page size is given. So we know that if page size is given, can I find the value of d? Yes or no? अगर पेज साइज दिया हुआ है, can I find the number of bits used for the offset address? Yes, we can find. So we know that. So what will happen? Now this your page size. Okay, page size will be equal to 2 to the power of d. D stands for your offset address into 1 byte. Fine. What is the page size? Page size is 4 KB. Page size is 4 KB. Okay. Now this will be equal to 2 to the power of 3 into 1 byte. Now I can write this one. 2 to equal to, now 4 can be written as 2 to the power of 2, and KB can be written as 2 to the power of 10, and this will be 1 byte divided by 1 byte. Now this goes cancel. Now this 2 to the power of d is equal to how much? 2 to the power of d is equal to 2 to the power of 12. Now d equal to how much? D equal to 12. Okay. Now this d value is equal to what? Now we have calculated this d value is equal to 12. Okay. Now this d value, the number of bits used for the offset address is 12. Now if I know that, if I know the number of value for d and number of total number of value, so how many bits are used per frame? How many bits are used per frame? Frame के लिए कितना use होगा? If total is 28, 12 is used for the offset address, then frame के लिए it will be 28 minus 12, which will be 16 bit. Is that clear? Is it clear? So f के लिए कितना use हो रहा है? 16 bit. Now यहाँ पर कितना use होगा? Now this f will be how many bit addressing? Now this will be 16 bit addressing. I am using 16 bit. That is almost equal to how many bytes? I can type 2 bytes. That means each of this पेज टेबल में जो फ्रेम है, ठीक है, कितने बाइट्स का होगा? वो 2 बाइट्स का है. Is it clear to all of you? Now each of this block is exactly 2 bytes. Each of this block is exactly 2 bytes. Each of this block is exactly 2 bytes. Why it is 2 bytes? क्योंकि वो फ्रेम का एड्रेस स्टोर कर रहा है और फ्रेम का एड्रेस स्टोर करने के कितना बाइट चाहिए हमें? 16 बाइट चाहिए, सॉरी बिट चाहिए. That means 2 bytes. Is it clear to all of you still now? Is it clear? Yes or no?
Yes, sir.
Clear? So why we are taking 2 byte? 2 byte क्यों ले रहे हैं? क्योंकि ये जो है फ्रेम का एड्रेस को स्टोर कर रहा है और फ्रेम का एड्रेस के लिए कितना बिट चाहिए? 16 बिट. It's almost equal to 2 byte. So now what next given? Logical address is given. So I know that what is the logical address? How many bits are used for the logical address? Now you can see 40 bits are used for logical address. Now 40 bits are used for logical address. Now we already calculate the value of d. What is the value of d here? Is 12. The value of d is 12. If value of d is 12, okay, if the value of d is 12, then what will be the value of p here? What will the value of p here? It will be 40 minus 12, which will be 28. Okay, yes or no? 40 minus 12, this will be 28. Fine. Now how to calculate the total number of now to calculate the size of the page table. Now I know that size of this page table will be, okay, size of this page table will be, size of this page table will be. Now suppose I am assuming there is n number of pages. Okay, how many pages are there? Now suppose there is n number of pages. Now it will be n, okay, n into size of each page. Size of each page कितना आपका? Now let me write size of each page will be 2 bytes. Right? Okay, now you have to calculate this in. That means how many pages are there? How many pages are available in your page table? Now see here. So what is the size of the process? Now suppose I'm saying this is my process P. Okay, this is my process P. Okay, now this process, suppose the process will be divided into number of pages. Now this process will be divided into number of pages. Now page 1, page 2, page 3, okay, page 4, page 5, like this. Okay, now we have to calculate how many pages is required. Now how many pages the process is required to store, so that the number of pages will equal to n. So how to calculate? Now what I know, so I know the process size and I know the each page size. Yes or no? Each page size how much? Now you can see each page size is 4 KB. Each of these 4 pages is 4 KB. है कि नहीं? और टोटल प्रोसेस का साइज कितना है? टोटल प्रोसेस का साइज है हम लोग का 4 MB. 4 MB. Okay. Each page size is what? 4 KB and total process is 4 MB. Then how many pages will require? The number of pages will be your process size. Okay, it will be equal to the process size divided by page size. Again, divided by page size. Yes or no? How to calculate n? So what is n? N is the number of pages required to store the process. Now I know the process size. Process size is this much, and size of the each page is this much. So if I divide the process size by size of the page, what I get? I will get how many pages do we require to store this process? Okay, this is n. Now in this case, what is the size of the process? The size of the process is given 4 MB. Okay, size of the process is 4 MB. And what is the size of the page? Size of the each page? Size of the each page is 4 KB. Size of the each page is 4 KB. Now if you multiply this, okay, if you divide this, it will be 4 goes cancel. Okay, now this will be, it will be something 1K, or it will be equal to 2 to the power of 10. Fine, 2 to the power of 10. Now what is the size of the page table? How to calculate size of page table? Now I know that size of the page table will be, it will be n number of pages into size of each, size of the each page table. Now what is the size of each page table? It's 2 byte. So it will be 2 to the power of 10 into 2 byte. So this can be written as how much? This is, I know this KB, so it will be 2 KB. So this is your size of the page table, which is your 2 KB. फाइन, यहाँ पर n को निकालना है, n क्या, नंबर ऑफ पेजेस कैसे आएगा? नाउ n कैन बी फॉर्मुलेटेड बाय दिस फॉर्मूला, प्रोसेस का साइज डिवाइडेड बाय पेज साइज. नाउ दिस पेज साइज रेफर्ड टू द सेकेंडरी मेमोरी. ओके, this will be give the value of n here. Okay, so once you get the value of this n, so I know that size of the page table will be what? It will be n into size of the each page table size, which will be 2 bytes equal to number of bits. Is it clear to all of you how we are calculating? So it is asked in many of time. Okay, then we basically ask this question. Okay, you have to find the size of the page table. How to find the size of the page table? So remember, to find the size of the page table, you have to know how many processes are there. First of all, how many pages are there? Okay, how many pages are there? Then what is the size of each page table? What is the size of each page table? Size of the each page table is nothing but number of bit used for the f. But if they are given some additional bit, now you have to add that one. Fine? Clear? Is it clear? Any doubt? Anyone having any doubt?
Sir, how did get a 1 kb equal to 2 to the power 10?
1 KB equal to the power of 10. It is like 2 to the power of 1, 2 to the power of 2. ठीक है, आप 2 to the power of 10 जब करोगे ना, multiply, so you will get exactly the value of 102. ठीक है, that is equal to 1
Equal to
KB.
1 kb.
हाँ, मैंने पहले क्लास में बताया था ना, ये 2 to the power of 10 जो होता है कितना होगा, 1024 बाइट जो होता है ना, 1024 बाइट is equal to how much? 1024 बाइट is equal to 1 KB.
1 kb. Yes, sir.
Any other doubt? So note down the question. So I will give one more question. Try this one. So first of all, note down this question. And if you are having any doubt, ask me. If you are having any doubt regarding this, if you are having any doubt, go ahead. Otherwise, copy this question. Note down this question. Once it is over, just tell me. So then I will give one more question to practice. Okay. Is it done?
Yes, sir.
Completed? Everyone? So
Yes, sir.
let me clear all this thing. Because there is number of numericals related to this one. Okay, they can ask in any way. Okay, किसी भी तरीके से पूछ सकते हो. बस जस्ट याद रखना, नंबर ऑफ, अगर आपको मेमोरी पता है तो नंबर ऑफ बिट निकाल सकते हैं, और नंबर ऑफ बिट पता है तो मेमोरी निकाल सकते हैं, साइज निकाल सकते हैं. ये दो टेक्निक याद रखना. उसके रिलेटेड क्या पूछा है उसके हिसाब से आपको फिर सॉल्व करना पड़ेगा. और पेज फ्रेम नंबर और पेज नंबर याद रखना. Page size
Sir,
refer to secondary memory. हाँ बोलिए.
sir, how to get a main memory?
What size of the main memory?
Yes, sir, size of the main memory.
Size of the main memory आपका logical address आएगा. Number of bits used for the logical address. Okay. Size of the main memory can be calculated by the number of bit. या 40 bit यूज किए ना, तो यहाँ पर size of the main memory क्या होगा? 2 to the power of 40. Okay. 2 to the power of 40 byte, which will be equal to your almost 1 TB. Clear? Fine.
Yes, sir.
And this physical address is associated with your uh, main memory. Okay. And this logical address is associated with your secondary memory. So already पहले क्लास में हमने डिस्कस किए थे कैसे करते हैं, very first class. Okay, same question. You have to calculate the size of this page table. Fine. Calculate the size of the page table, but यहाँ पर आपका along with the F. Okay. Now this page table consists of along with the F. There is 2 byte extra. We are using for the priority, or basically we can say invert bit table use करते हैं for storing the information, additional information. Okay. So what will the size of the
Yes, sir.
space here? Size of the space will be your frame size plus 2 byte. Okay. Remember this. अगर extra bit दिया है तो याद रखना यहाँ पर मतलब आपको ऐड करना, frame size को ऐड करना है. The question is given. The size of the main memory is given. Size of the main memory is given, which is your 64 MB. Fine. Then your logical address is given. Logical address uses 32 bytes. Then your page size is given. Okay, page size, which is referred to your secondary memory. What is size of my page? Which is your 4 KB. Okay. Now the process size is given. Process size is also given. What is my process size? Process size, which is your 8 MB. 8 MB. Now you have to calculate the size of the page table. Calculate the size of page table. Size of page table. Okay. And also calculate, second point, also calculate number of bits used for pages. Okay. P का P में कितने bits use होंगे? Number of bits used for pages. Yes. Solve this question. So how to solve first? Yeah.
प्रोसेस साइज 8 KB है.
हाँ, process size है आपका 4 KB. Sorry, page size है 4 KB. Process size है 8 MB. 8 MB. Process
Okay,
size is 8 MB. Process size is 8 MB. So what is given? Now this is given. This is equal to 64 MB. Fine. And what else given? Now this is also given. Logical address, which is your 32. Fine. Now there is page size is given. Now suppose this is my secondary memory. Secondary memory का each page size दिया हुआ. Each page size is 4 KB. 4 KB. What else given? There is a process P whose size is 8 MB. 8 MB. The process P है. Now if I say this is my process P. Okay. Now suppose this is now number of pages is going to store. Page 1, I will name as the page 1, page 2, okay, page 3. So I don't know how many pages is required. So you have to calculate how many pages is required. Okay, like this is stored. All these pages of 4 KB. So how to start? So first what we have to calculate? So first of all, what we have to calculate? So what will be my physical address? How many bits are required for this physical address?
26.
So
26.
we require 26 bits. Okay. So how many bits are required for physical address? Now 26 bits is required. Fine, good. Then how many bits for the use for the offset? How many bits we are used for the offset?
12.
12.
So how we get? So how we are getting 26 is very simple. Now we know that 64 MB. Suppose I said this is using m bit. Now this will be equal to 2 to the power of n. Now from this we get m equal to 26. Okay. Now to calculate the, I will use the page size help. Okay. So I know that page size is equal to what? 2 to the power of into 1 byte. Byte address. No? So we know that page size is given 4 KB. Okay. So it will be equal to 2 to the power of D. So from D we get how much? 12. Now this is 12. Now we are getting this. Now this is 12. Okay, this is 12. And total 26. So what is the value of F? What is the value of F here? How many bits for F?
14.
14 bit for F. Now there is 14 bit for F. Okay. So I will come back to here before let me solve this one. So 32. Now out of 32, 12 is for the D. Then how many bits for the P? How many bits for the P?
20.
20.
20.
Fine. Now we know that we are already know that every process has its own page table. Okay. Now I have to calculate this size of this page table. Fine. So now what will happen? Now each page table का size कितना होगा? Each frame, each box दिख रहा है ना? इसको बोलते हैं each frame of page table. Now each frame of page table size will be it will be f plus 2. f plus 2. Now f क्या है आपका? फ्रेम एड्रेस को स्टोर करता है और फ्रेम एड्रेस के लिए हम लोगों ने कितना बिट यूज किया है? 14 बिट. So it will be 14 plus 2, which is your how many bytes? This is your 16 bit,
2.
nothing but 2 bytes. Fine. One thing you remember here, note कर लो यहाँ पर point देके. We will always take the closest integer. Suppose यहाँ पर 2 नहीं दिया होता. Suppose assume that 2 is not given. Now what will the size of this frame? It will be equal to f, which will be equal to 14. है कि नहीं? Now on that case, you have to round off to 2 byte also. याद रहेगा ये बात? Yes, it is clear. Always you have to round off to higher integer. Okay. If it is 14 bit like, suppose 2 is not given. So what is there? Now f will be 14. So always we have to convert to the byte and we always go for the nearest one. Now if suppose f equal
पॉइंट
to
में
50,
नहीं ले सकते हैं सर.
पॉइंट पे नहीं लेंगे क्योंकि हम बेसिकली उसको मेमोरी में कन्वर्ट करेंगे ना. एंड मेमोरी हमेशा we will take in terms of byte, kilobyte और megabyte. What is the basic? What is the unit? Unit क्या है इसका? मेमोरी का सबसे लोएस्ट यूनिट जो बाइट है, इसलिए हम उसको बाइट में कन्वर्ट करते हैं. ऐसा में इसको कन्वर्ट कर रहे हैं. 15 होगा तब भी आपको 2 बाइट लेना है. ठीक है. 13 होगा तब भी 2 बाइट लेना है. Fine, because we have to convert to the byte. Fine. So to remember this thing, okay. So in this case, it's 2 byte. Okay. Now next, what I have to calculate? Now I know this one. I know the size of this one. Okay. I have to calculate the page table size. So for that, what I require? I require how many pages are there? How many pages are there? How many pages are there? So how to find number of pages? So number of pages will be equal to what? Process size. Process का जो size है कि नहीं? Process size divided by what? Process size divided by page size. है कि नहीं?
Page size.
Why क्यों बोल रहे हैं? Because में process बोल रहे हैं. Suppose process है आपका, suppose process इतना बड़ा है, इतना बड़ा process कर रहे हैं, ठीक है? लेकिन मेरा page size है suppose इतना ही है. तो जब मैं इसको इससे divide करूँगा तो क्या देगा? Now it will tell me how many blocks of this size, how many blocks of this size I require. So it will divide into some like this. So what these are the number of pages. Now it will be P1, P2, P3, P4, P5. So it will give the number of pages. Now in this case, what is the process size? What is the process size? It is 8 MB.
8 MB.
And what is the page size? Page size is your 4 KB.
4 KB.
Size is 4 KB. Now, अगर आप इसको cancel करोगे, now this goes 2 times. Okay. Now this KBN, अगर problem हो रहा है, now you can cancel like this. This is 2. MB का क्या था? MB is nothing but 2 to the power of
2 to
20
the power 10.
and KB is 2 to the power of 10. Now we cancel what I left with. It is left with 2 into 2 to the power of 10. Now it is something 2 to the power of 10 क्या आपका 1024 which is 2 what? 2K. ठीक है? It is 2K. Fine. So number of pages is 2KB. Or you can take it is not 2KB, it is 2K. It will be 2K. Or you can write like this also 2 to the power of 11 before getting confused. It is 2K, okay, or 2 to the power of 11. Then what finally we have to calculate? Now finally I have to calculate size of the page table. Yes or no? Now what is size of page table? It will be n. What is n? N is equal to 2 to the power of 11 into size of each frame. The size of each frame is 2 byte. Now if I multiply this, it will be 2 into this 2 into 2 to the power of 10 byte. Now how much this will be? 2 into 4 and this is KB, so it will be 4 KB. So what is my page size? It is my table. Size of the page table. Size of the page table is 4 KB. Is it clear to all of you? Or still having any doubt? Yes, any doubt?
No, sir.
Clear? So just note down. Yes, go ahead. पूछिए. पूछो क्या doubt है? Any doubt?
No,
सर
sir, no doubt.
Okay, just note down.
सर
हाँ, पूछिए.
सर जब नंबर ऑफ बिट्स निकालेंगे पेज टेबल के लिए तो वहाँ पे 2 बाइट लेना होगा ना?
नहीं 2 by 3 लेंगे ना. देखो नंबर ऑफ पेज
नहीं
निकालने.
नहीं सर, सब जब निकालते टाइम जब ईच पेज का साइज लेंगे तो 2 बाइट लेंगे ना?
ये चीज में कंफ्यूज नहीं होना. अगर पेज टेबल में ले रहे हैं हम लोग, पेज टेबल में ले रहे हैं, ठीक है, पेज टेबल में जो साइज होगा वो अलग रहेगा, वो पेज साइज नहीं है. आपका पेज साइज मतलब आपका होता है सेकेंडरी मेमोरी का पेज साइज, विच विल बी इक्वल टू योर फ्रेम साइज, दिस वन मेन मेमोरी. ठीक है, लेकिन अब ये डिफरेंस होता है, ये आपस सेम होता है. ये क्या स्टोर करता है? अगर हम पेज टेबल में देखेंगे एंट्री, पेज टेबल का एंट्री रहता है आपका पेज नंबर, उसके रेफरेंस में फ्रेम का एड्रेस, फ्रेम नंबर का एड्रेस. अगर मैं बोलूँगा सपोज पेज नंबर 5, सपोज दिस इज माय पेज नंबर 5, सपोज हम उसको फ्रेम नंबर 7 में स्टोर किए, सपोज फ्रेम 7, दिस इज माय फ्रेम 7. ओके, सो अब मेरे को ये इसको अभी क्या करना है, पेज 5 को अभी इसको रेफरेंस में करना है. तो मैं क्या बोलूँगा आपको, नाउ पेज 5 का रेफरेंस कहाँ से? पेज 7. तो पेज 7 का क्या करेगा, वो एड्रेस को स्टोर किया है. इसमें जो पेज टेबल में जो स्टोर किया है, क्या स्टोर किया है? एड्रेस को स्टोर किया है. और एड्रेस को स्टोर करने के लिए, फ्रेम एड्रेस को स्टोर करने के लिए कितना बिट हम लोग यूज कर रहे हैं? कितना बिट यूज कर रहे हैं? 14 बिट यूज कर रहे हैं. तो यहाँ पर आपका जो है ये 14 बिट प्लस 2 एडिशनल बिट, दैट इज 16 बिट. 16 बिट मतलब 2 बाइट. मतलब ये हो गया पेज टेबल का ईच एंट्री का साइज 2 बाइट. लेकिन पेज साइज क्या आपका? पेज साइज जो है आपका 4 KB है. ओके, सेकेंडरी मेमोरी में ईच पेज का साइज है 4 KB. इसलिए जब हम लोग ने टोटल प्रोसेस को 4 KB से डिवाइड किया तो हम लोग को क्या मिल गया? नंबर ऑफ पेजेस मिल गया. मतलब अब वो टोटल प्रोसेस मेरे पास कितना है? 8 MB है कि नहीं? टोटल प्रोसेस में 8 MB का है. और ईच ब्लॉक में हम कितना स्टोर कर सकते हैं? ईच ब्लॉक में हम लोग मैक्सिमम 4 KB स्टोर कर सकते हैं. तो कितना ब्लॉक चाहिए मुझे? हाउ मेनी ब्लॉक्स आई रिक्वायर्ड? Okay, how many blocks are simple now? It will be 8 MB by 4 KB. So what I will get? I will get number of blocks or number of pages I require, which will be equal to same. क्योंकि जितना प्रोसेस का नंबर ऑफ पेज होगा यहाँ पर आपको देना है. लेकिन अब यहाँ पर जो होगा पेज टेबल में जो साइज होगा इस बॉक्स का, वो आपका 2 बाइट होगा. इसलिए पेज टेबल का साइज क्या हो गया? नंबर ऑफ पेजेस इनटू साइज ऑफ ईच बॉक्स. गेटिंग माय पॉइंट? इज इट क्लियर?
यस सर. तो सर जब बिट्स इसका निकालेंगे पेज टेबल का, तो उस टाइम पे ईच पेज का साइज तो 2 KB लेंगे ना
2 बाइट
पेज
लेंगे.
टेबल के लिए?
हाँ, पेज टेबल
यस
के
सर, 2 बाइट.
2 बाइट.
यस सर.
Right.
यस सर.
हाँ. और सेकेंडरी मेमोरी में जब निकालोगे तब आप लोगे 4 KB टोटल नंबर ऑफ पेजेस लेंगे हम लोग। अब सब प्रोसेस के लेंगे, ठीक है। यहाँ क्या था, एक प्रोसेस का सपोज मेरे पास 5 प्रोसेस, सेकेंडरी मेमोरी में 5 प्रोसेस है, तब क्या होगा सब प्रोसेस के लिए इंटू 4 KB वो आपको सेकेंडरी मेमोरी देगा, या फिर लॉजिकल एड्रेस से दैट विल बी 2 to the power 32। दिस इज माय टोटल मेमोरी। Okay, any other doubt? So this is your topic. Okay, topic for second internal is your process synchronization. So what we have learned about process synchronization, like what is critical section problem, what is hardware solution, and we have something little bit learn about the semaphores. Okay. Along with that, we will have the memory management. Memory management में आपका non-continuous allocation and continuous allocation up to paging. Okay, paging almost complete हो गया. Only one more topic is there in paging. So after the paging will complete. Okay. So up to paging, what we have discussed till now. Okay. So any doubt regarding that? We are left with only 2 minutes. So if you are having any doubt regarding your syllabus or anything,
सर इंटरनल का सिलेबस क्या रहेगा?
वही बताया ना, प्रोसेस सिंक्रोनाइजेशन। ओके, प्रोसेस सिंक्रोनाइजेशन एंड मेमोरी मैनेजमेंट। मेमोरी मैनेजमेंट में भी पेजिंग तक, ओनली अप टू पेजिंग। प्रोसेस सिंक्रोनाइजेशन कंप्लीट प्रोसेस सिंक्रोनाइजेशन। ओके, देन योर मेमोरी मैनेजमेंट अप टू पेजिंग। फाइन, क्लियर? इज इट क्लियर? ओके,
सर उससे पहले का नहीं रहेगा ना?
पहले का कुछ भी नहीं रहेगा, पहले का जितना पढ़ा कुछ भी नहीं रहेगा आपका। प्रोसेस कॉन्सेप्ट, ओके, तो उसके पहले शेड्यूलिंग वगैरह कुछ नहीं रहेगा। शायद इससे क्वेश्चन जैसे कि हम फॉर्म पढ़ाए थे ना, प्रोसेस चाइल्ड प्रोसेस वाला, उससे एक दो क्वेश्चन रहेगा। फाइन, फोक सिस्टम कॉन्सेप्ट, चाइल्ड, हाउ टू क्रिएट चाइल्ड प्रोसेस, हाउ टू क्रिएट अ चाइल्ड प्रोसेस। So any other questions, any other doubts? Anyone having any other doubts?